Okay, so here we go. Common logarithm. Okay, the common logarithm. A logarithm with base 10 is called a common logarithm, and we write it without the base. Okay, so you will probably never see it written log base 10 of x. You will probably just see log of x. Okay, you probably will not see it written as log base 10 of x. You will see it written as log of x. Okay, so if you don't see a base, know that it's equal to 10. All right, so remember yesterday what we talked about with the relationship between logarithms and exponentials. Okay, I'm going to rewrite that relationship right here. Log base b of a is equal to x. Is that what we had? Is that where the x was? Or was the x on in the other spot? That's right. Okay. So if we have log base b of a is equal to x, then that means b to the x is equal to a. Okay, that was our relationship between the logs and the exponentials. So y'all did great converting between those two forms. But now let's use that to actually evaluate a logarithm. So log base 7 of 49. What that's saying is 7 to some power is equal to 49. 7 to some power is equal to 49. So what is that power? Squared. Second power, squared, however you want to phrase it. It's equal to 2. Guess what? You can check these, guys. Remember yesterday when we were putting it in exponential form? Use the swoop. Make sure that's a true statement. Okay? Write it like this. 7 squared is equal to 49. Okay, yes, I know that's true. Okay? So number 14. Log base 3 of 27. 3 to what power is 27? The third. Okay? Make sure it's true. 3 to the third equals 27. Okay, we're good. Okay, number 15. The log of 100. We just did this one a second ago. If there's no base, it's understood to be 10. And 10 squared is 100. You can even write you a little 10 in there if you want to. Okay, 10 squared is 100. All right, now, we're going to have to think a little bit on number 16. Okay, 12 to what power is equal to 1? Very good. 0. 12 to the 0 is 1. Y'all got to know that rule right there. Anything to the 0 power is 1. Anything to the 0 power is 1. So we also need to tuck back into our mind that anytime we see a log of 1, that answer is going to be 0. Okay, that answer is going to be 0. Any log, doesn't matter what the base is, a log of 1, the answer is 0 because that base to the 0 power is 1. Okay, how about number 17? The 6th. We had to do a little work to get that one because our charts only go to the 4th. 2 to the 4th is 16, so if we keep multiplying by 2, multiply by it one more time, we get 32. Multiply by it again, we get 64. 2 to the 6th is 64. Okay, how about log base 3 of 243? 5, very good. 3 to the 5th is 243. Ooh, number 19. Log base 9 of 1 over 81. -2, very good. Okay, 9 squared is 81, but it's in the denominator, so we got to give it a negative exponent. Very good. Now, we got to think about 20 here. Okay, 4, what's the relationship, what's the exponential relationship between 4 and 64? 4 and 64, where does that fall into place? 4 cubed is 64, but is our base 4? No, our base is 64. So if 4 cubed is 64, what can we do to 64 to get 4? Does that make sense? what can we do? How do we go the other way? If 4 cubed is 64, then how can we get this equation right here equal to just 4? How can we get that 4 by itself? What's the opposite of cubing something? What's the opposite of cubing something? Cube root, okay, the cube root. So 4 is equal to the cubed root of 64, okay? Now, does anybody remember from Math 2 how we can express the cubed root as an exponent? Anybody remember that? How to express the cubed root as an exponent? It was a fraction, the 1/3, okay? The cubed root is the same as the 1/3 power. The cubed root is the same as the 1/3 power. So 64 to the 1/3 equals 4. 64 to the 1/3 equals 4. If you don't believe me, type it into your calculator, okay? 64 raised to the, you gotta put in parentheses, 1/3 is 4. Okay? Now, I'm getting ready to show you something that will let you figure out things like number 20 when it's not quite so obvious what the answer is. Okay? So I'm getting ready to show you something that'll help you with things like 20. Because I know that one was hard. Okay, so let's look at the bottom of the page there. It's labeled change of base formula. Okay, so your calculator has a log button on it. Okay, but it's just the common log. It's the base 10. And you don't have the option of changing the base on there. But there is a formula to change the base. Now, it's called a formula. It's not that complicated. Okay, what it says is you've got log base b of a. That is equal to the log of a divided by the log of b. That's how you can evaluate on your calculator. The log of a divided by the log of b. So the base, the subscript, the part on the bottom goes on the bottom. Okay? That's how I remember the order of it. So, looking at number 21, log base 16 of 64. 16, we can't raise 16 to a whole number power and get 64. Now, they're kind of related, right? Because they're both base 4. 16 is a power of 4, 64 is a power of 4, but they're not directly related. So, change of base says that the log of 64 divided by the log of 16, if we type that into our calculator, that will let us figure out what this answer is. Now, here's where most people mess up. You have to close the parentheses after the 64. When you press the log button, it automatically starts a set of parentheses, so you have to close the parentheses after the 64 before you put divided by the log of 16. Okay? I prefer fractions over decimals. Okay, so I'm going to write that as 3 over 2. So that says 16 raised to the 3 over 2 is equal to 64. Okay. Number 22 is similar to this. 8 and 32. 32 is not a power of 8, but they could both be written as powers of 2. But we're not going to stress out over that. We're just going to put the log of 32 divided by the log of 8 into our calculators. And we're going to get this number that we can express as 5/3. Okay, so that says 8 raised to the 5/3 is 32. Okay? Easy stuff. You just got to remember how to put it in your calculator. Now, 23. Log base 2 of 54. 54 is not a power of 2. So we have to rely on our calculator here. Log of 54 divided by the log of 2. I'm writing it And I encourage you to write it before you type it into your calculator, because a lot of people will forget this simple concept here, and they'll be totally lost as to how to answer these questions. So if you write it, it's more likely, the more you write it, the more likely you are to remember it. This one cannot be turned into a fraction, so we just have to approximate it. That's why my equal sign looks squiggly. That means approximately 5.755. I like to round to 3 numbers after the decimal. Now, 24. They put the base of 10, which I told you most of the time you're not going to see a base of 10, and you're really most of the time not going to see a base of 10. But they put it there to make you think you have to do change of base. You really don't have to do change of base with number 24, because the base on the calculator is base 10. So really all you have to do is type in the log of 294. Now, if you were just on the change of base train and you weren't thinking about it and you went ahead and did it anyways, guess what? You're still going to get the right answer, because the log of 10 is just 1. Okay, the log of 10 is 1, because 10 raised to the first power is 10. So it doesn't change your answer there. It's not going to mess you up if you use the change of base, but I just wanted to point out that you really didn't have to. Okay, 25. Log of 136 divided by the log of 4. Log 136 divided by the log of 4. Approximately 3.544. And one more. The log of 1 over 36 over the log of 6 is negative 2. Did we really have to use our calculator for that one? No, we really didn't. Okay, we didn't have to, but it's still on there to show you that even with ones that we know how to evaluate, if we had taken a second to look at that and said, oh, well, 6 raised to the negative second is 1 over 36, I can figure that out, I know that, change base still works, okay? Change base still works. So if you forget how to evaluate your logarithms, you can still use your change of base to figure those out, okay? So another simple concept